right. All right. Let's see how we did. Everybody good with the area being 1 square meter? All right. Everybody good with the area there being 10,000 square centimeters? All good. Okay. Are they congruent? If so, then their areas should be what if they're congruent figures? Whenever we have congruent figures, what should be true about their areas? Equal. Good job. They should be equal. All right. So based upon that, 1 square meter is equivalent to how many square centimeters? 10,000. Make sense? All right, so congruent figures, you got the same area. All right, and then circle the following correct response, true or false. To convert between units in area, you can multiply or divide by the given conversion rate. Example, 100 square centimeters equals 1 square meter. If you look up top, is that true or false? Look at your work up top. You got 1 meter squared equivalent to something there. Is that the same as the value there? No, so that would be what? False. All right, that would be false. Conclusion, to convert between measurements, we would multiply or divide by the S. What do you think? Big area. What do we do to find area? Sum? What do we do? What do we label area with? What exponent? When we label our square. All right, so we're going to multiply by the square of the conversion rate. All right, so we touched on this a little bit last week. All right, you do not just convert using the conversion rate, you convert by the square. So for example, if I'm converting feet to inches, how many inches in a foot? Rhymes with 12. 12. But I'm not going to multiply by 12. Instead, I'm going to multiply by what? 12 squared. Which, of course, we all know our times tables is 144. So 3 times 144 is 432 inches squared. All right. All good? Make sense? So whenever we're converting, we do not multiply by the conversion rate. We multiply by the square of the conversion. All good? Okay. So that gets you through tonight's homework on area of rectangles, triangles, and parallelograms. Tomorrow's class, we will start with a review of that. So now we're moving on to 10.2. You want to do it there tomorrow? Okay. You're welcome. You're welcome. So, Izzy. You're welcome. No worries. You're welcome. You're welcome. No problem. You got that back rest, you guys in the back now. I'm supposed to the whole ledge in the middle of my probably your shoulder. You're as far away as you possibly be. If you need me, I'll just send a message. Oh, I'm gonna get a couple more. Wow, oh, this is new for me. All these people, I feel a lot of pressure. Okay. Geometry classes, it varies. It can be as much as 30. Depends on how many sections there are. This one has 27. Usually if I have like 3 sections, one of them is a little smaller, like in the 20s, and then they're in the middle and big. If I only have 2 sections, then they're kind of pretty big. All right. So here's the idea. All right. Rhombus and a kite. Rhombus. All right, so we're looking at a rhombus. Definition, all sides are congruent. All right, we're dealing with area, and we said that whenever we're doing area of a figure without circles last week, they're always going to be perpendicular. How does that impact the rhombus at all? What's true about a rhombus that allows us to bring up perpendicular dimensions? What's true about them? The diagonals are perpendicular, perfect. Okay, the diagonals are perpendicular. That allows us to get the area, all right? So basically, I'm going to call this D1 divided by 2, and that's D1 divided by 2. Because a rhombus is a special type of parallelogram, the diagonals bisect each other, correct? So each one of those is half the diagonal. Now I'm going to come over here, D2 over 2, D2 over 2. All right? Make sense? All right, now, what happens is the diagonals divide that into 4 congruent triangles. We already dealt with that in chapter 6. And remember, the area is 1/2 D1 D2, correct? 1/2 base times height. So the area of this would be 1/2, all right, D1 over 2, D2 over 2. Zoom in. Does that make sense to everybody from last week? Every triangle is 1/2 base times the height. All right, so now I'm going to multiply all my denominators together. 2 times 2 is 4. 4 times 2 is 8. So at the end of the day, the area of each triangle is going to be 1/8, all right, D1 over D2. Everybody agree with that? How many triangles do I have total? 4. Are they all congruent? Yep. So to get the area of the whole figure, what's the quick and easy way to do it based on what I have? All 4 are congruent. I have the area of 1. What's going to be the easiest way to get the area of the whole figure? Multiply by 4. So I'm going to take 1/8 D1 D2 and multiply by 4. Do that for me. Give me a simplified variable expression. So multiply that times 4 and tell me what the simplified variable expression would be. 4 times 1/8 is 4/8. What does 4/8 reduce down to at the end of the day? 1/2. Ladies and gentlemen, you got yourself area of a rhombus. 1/2 the product of the diagonals. So area equals 1/2 D1 D2. All right. Area equals 1/2 D1 D2. Now, for the kite, all right, and again, I would love to have been able to cut all these out, but given all the scissors and having to collect all the scissors and sanitizing all the scissors, for everybody's safety, we're going to hold off and just display it for you. So here's a kite. What does a kite share? What property does a kite share with a rhombus? Diagonals are also perpendicular. Make sense? That's why we're doing these two together. So its diagonals are also perpendicular. But here's what I'm going to do. Similar to what I did last week with the triangle with Sketchpad, I'm going to cut it right in half. All right? Would you agree with me that those two triangles are congruent to each other? All right, so here's what I'm going to do. I'm going to take this bottom half, all right, and see if I can remember how to do this. Oh, look it. I did. All right, look it. I did. Let me get a piece of paper underneath so we can figure this all out. Okay? If I rotate that bottom half up and around, what shape from last week do I now have? And let's outline it to make it easier for everybody because it's kind of hard. All right. What shape do I have? Rhymes with parallelogram. Parallelogram. What's the area of a parallelogram? Base times height. Okay. Well, that's a diagonal, but what fraction of the diagonal? It's half. It gets bisected. Everybody remembers that from chapter 6? So that's 1/2 D1. And then right here, we have the whole length of that diagonal. So the base is D2, and the height is 1/2 D1. For pure looks, appearances, all that mumbo jumbo, what do we normally do with the 1/2? Put it first. Ladies and gentlemen, guess what formula you once again have? 1/2 D1 D2. 1/2 D1 D2. Good? All right, let's take some notes. 10.2, put them up here. Slideshow from current slide. Enable editing. Slideshow from current slide. Oops, didn't want that. Window P. Duplicate, not extend. Slideshow from beginning, and now we're good to go. Our objective is to find the area of. All right. A trapezoid, rhombus, or kite. The area of a trapezoid is, you got to jot that down. The area of a trapezoid is 1/2 the product of the height and the sum of the bases. Area equals 1/2. All right, if you want to write that next to it, area equals 1/2 height, B1 plus B2. Area equals 1/2 height, B1 plus B2 is the one you're going to want to add at the end. You'll get a reference sheet before Friday's quiz that you'll be able to use. And you will take your quiz in class. You will have the same resources available to you that people at home would have. So you can use a computer if you want. We'll have Chromebooks. You can use anything you want. Your notes, doesn't matter to me, but you're going to take it in class. All right? So why is the area of a trapezoid 1/2 height, base 1 plus base 2? If I can get everything closed down. Here we go. All right. I'm going to make myself a trapezoid. And I'm going to make sure I don't make it isosceles because I don't want that to get in the way of knowledge. All right. So I'm going to make a point up here. And I'm just going to create a parallel line because that's the definition of a trapezoid. All right. Then I'll connect that to form one of my legs. I will create a point on that line to create my other leg. I will connect those 2 points to get my parallel base, and boom, I have myself a trapezoid. Good? Okay, so here's what I do. I connect the midpoints. What do we call that segment? Mid-segment. Okay? And what I do is I rotate the entire figure like such. And when I do that, what type of figure am I back to? Parallelogram. Everything's based on parallelograms. So instead of B1 and B2, you guys okay if I call my bases X and Y? So there's X, there's Y. These are congruent, correct? So that same Y would be up top. All right? And since those are congruent, the same X would be down here. All right? Now, I'm going to take that, construct a perpendicular line. All right? And that perpendicular line is the what? The original trapezoid. Lines with height. Height. The altitude. Okay? Is that also the height of the parallelogram? Absolutely. So I'm just going to call that H. I'm just going to call that H. So the area of the parallelogram equals X plus Y times H. Well, what does X plus Y represent? Sum of the bases. Sum of the bases. Okay? So X plus Y is simply the sum of the bases. So you just wrote it down as 1/2 height B1 plus B2. So that's where the sum of the bases comes from. Where does the 1/2 come from? Well, obviously, each part of the trapezoid is what fraction of the final parallelogram. Okay. Good. Perfect. All right. Okay. The area of the rhombus or kite is half the product of the lengths of the diagonals. The area of a kite or rhombus or kite is half the product of the lengths of the diagonals. 1/2 D1, D2. All right, now we're going to go through these. That's about it, but keep in mind. Now we're going to go through these, but just to give you an idea visually of what we're looking at. Keep in mind the possibility of. All right, so this is in your notes there. The possibility of special right triangles created by other diagonals or other sides of the figure. Anybody need to see what that means visually? I can sketch it out. Okay, so keep in mind you could have, all right, a kite where this is 45 degrees. All right, and they tell you that this is 8. I would expect you to know that that is 4√2, and that is also 4√2. Got me? All right, and with a rhombus, let's say it's a rhombus. All right, if we tell you this is, let's say, 30 degrees. All right, and that's 12. I would expect you to be able to find those side lengths as well, 6 and 6√3 in order to get the areas. That's what we mean by that. Converting units. So, for example, is it possible they give you a problem where one of the units is in feet and some are in inches? Yes, so you got to convert. I would strongly suggest you convert in the beginning, correct? Because that's going to make our life easier. Algebraic dimensions, solving quadratics. Does anybody need to see that? And what it would look like? Got no problem sketching it out. It's not a big deal. All right, so I'm going to slide over here a little bit. So basically the idea is this might be x plus 1. That may be x. And let me put a number in my head. It would be 12. What's two numbers? 112. This would be 11. And area equals 112. And this is going to be our focus over the next couple of days. So you might get a problem that looks like that. You have to realize if that's x plus 1, this one's also what? x plus 1. All right. And again, these are just quick ideas of what you're going to be expected of. You're not going to have to do it tonight for homework or anything like that. So area would be 1/2 d1 d2, correct? They tell you the area is 112. All right. d1 could be the x plus 11. The d2 could be x plus 2x plus 2. And then you solve it from there using quadratic. All right, so that's what we're talking about there. All right. Angle measures in trigonometry. All right, so in other words, really quick, if that's 34 degrees and that's 12, can you then use trig to find the dimensions of the diagonals rounded? Yes. And that will, of course, give you a hint because what will it say? Round, because they're not exact values. And then coordinate geometry, distance formula to find dimensions. All right. So this may be a kite. All right. And these usually aren't bad because those are horizontal and vertical lines. But maybe we do that. And then you got to use distance formula and the coordinates together. All right. But please keep in mind with a rhombus and kite, it's all based upon diagonals. All right. Good. All right. Let's do some examples. All right. So number 2, area equals 1/2 the height, which is 5.5. And then the 2 bases added up, which is 14 plus 6. I'm all about working smarter, not harder. What are you going to do first? Add 14 and 6. And then divide by 2. Everybody see how we can do it in any order we want. 14 plus 6 is what? 20. What's half of 20? 10. And 10 times 5.5. 55. That may be the difference for some of you of having enough time on the quiz. By identifying the fastest way to do this. All right, and that would be 55. What is the original unit? Inches, and what exponent do we add alongside it? Squared. All right, number 3, there's no such advantage. We do 1/2, the height is 5, and the 2 bases are 8 and 3, which would be 11. When you show your work on this assignment, you can either show the original 8 plus 3 or their sum. I don't care, but that's all you got to show for work, is what you plugged into the formula. All right. 5 times 11 is 55. Half of 55 is 27.5 meters squared. So when you show your work, that's all we're looking for. All right. Any questions about finding the area of a trapezoid? For those of you interested in extra practice to help yourselves, 16 and 7 is 23. 23 times 9 is 207. Half of that would be 103.5 inches squared. And then the next one, area of trapezoid with base is 5 and 11. That's a break 8. 8 times 7.4 would be 59.2 square feet. Now, we start with number 6. And the first thing we identify is, if this is 14 up here, and those are perpendicular, what is that got to be down there as well? 14. Everybody see that visually? All right. If that part is 14 and that part is 16, to get the base, what are we going to do with 14 and 16? Add them up for 30. The problem is I do not have my what? Height. This is a right angle, makes that a right triangle. I got 2 dimensions of a right triangle. What theorem kicks in? Pythagorean or triples. Either way you want to go about it, but that ends up being 12 millimeters when you do Pythagorean theorem. All right. So now I'm going to come on over. Area equals 1/2, 12. And then the two bases are 30 and 14, which adds up to 44. Half of 12, 6. 6 times 44 is 264 millimeters squared. Number 7, instead of dimensions, what are they giving me right smack dab at the vertex over there? An angle measure, 60 degrees, which means what type of triangle? 30, 60, 90. Shortest side is half the hypotenuse. What is half of 12? 6. All right, and then up top, opposite the 60 would be 6√3. Again, if this is 30 inches down on the bottom, what's it got to be up top? 30 inches. Area equals 1/2 the height, which is 6√3. And then the two bases added up. 36 plus 30. All right. 36 plus 30 is 66. Now, you have a choice. You can either do half of 6√3 or half of 66. Doesn't matter to me. But if you do half of 6√3, realize that only affects the outside number. What's half of 6, the outside number? So that expression will be 3√3. And now I would like to have everybody's attention. Ladies and gentlemen, exact and what it means. For those of you that continue to put decimals down and are wrong. Exact is not a decimal with 42 digits. It isn't. Exact is exact. When you multiply those together, you're going to multiply the 3 times the 66. And that would be 198√3 inches squared. All right, that's exact. So no one's going to contact me or ask me during a quiz what it means by exact. That's exact. Do you hear me? All right, I'll go loud. I yelled me on the computer. All right, so if I look at the one on the right, once again, what is the missing dimension for the one on the right? The height. So what theorem are we going to use to find the height? Mine's with Pythagorean. Pythagorean. I got 12 and 14. So 12 squared plus x squared equals 14 squared. The heights there, we're just missing the part of the base. 12 squared is 144. 14 squared is 196. How am I going to get rid of the plus 144? Subtract. X squared equals 52. X equals 2√13. So that means that dimension is 2√13. All right, up here we got 8, so that will be 8. Now I'm going to do the area. 1/2. Everybody good with 1/2 because it's a trapezoid. The height is 12. And then the two bases are 8 plus 8 plus 2√13. Before moving forward, does everybody understand that? All good? All right, what's half of 12? 6. Good with that. Can I put 8 and 8 together? Yep, that's going to give me 16 plus 2√13. What am I then going to do with that 6? Rhymes with mistribute. Distribute. 96 plus 12√13. The original unit is yards, so the final unit is yards squared. Any questions about trapezoids? All right. So tomorrow we will finish those notes up. Okay. If you need to grab a paper copy of either the 10-1 practice, which is due tonight, or the 10-2 practice that's going to be due tomorrow night, they're up here. All right. Okay, 10-1's up here, 10-2's up here. 10-1 is due tonight. 10-2 is going to be due tomorrow night. We'll finish rhombi and kites tomorrow after going over the 10-1 homework. Those of you at home, if you don't have any questions, have yourselves a lovely day. Finish that. We go back to Google. We will stop presenting. All right, we will stop recording. And again, if you're looking for extra help,